Hello everyone, you're welcome to another lesson on Math with Air. So today, again at the request of one of our followers, we are going to start with differentiation and then move to integration. So in today's lesson, we are going to look at differentiation and some of the methods which we can use to differentiate a function. And some of these methods include the general method, the chain rule, the product rule, and the quotient rule. So this video is dedicated to these four methods of integration of differentiation. So what is differentiation? Differentiation simply means finding the rate of change of a function with respect to some variable. What do we mean? If we have, for example, a function y, if we say y the function of x as such, that is y is equal to f of x, then the derivative of y with respect to x is written as dy by dx will simply be f prime of x. So these are two different notations that mean the same thing, differentiation. And the right dy by dx, that is the change of y with respect to x, and it could be written as just f prime of x, that is how y changes with respect to x. So that is just the little introduction we have about differentiation. Now we go straight away without wasting so much time to look at the different methods of differentiation. So the first method we have here is the general method. That is, if we have y given as a function of x as a x raised to the power n, where a here is a constant, where a is a constant, then dy by dx, or differentiating y with respect to x, will just be equal to the power of x. You bring it down and you multiply it with the constant, write back the x, and then we subtract 1 from that power. That is, we bring down this power n, multiply it by the constant, we write the x, and we subtract 1 from the power. Let us illustrate this using an example or some examples. So find dy by dx given that a y equal 3, x raised to the power 4, b y equal 2x cubed plus 7x, and c y is equal to 5. So let us do this using the general method. So we write here solution. We use the general method to solve these examples. The first one, we have y equal 3, x raised to the power 4. So going by this our formula here, dy by dx be equal to, first thing is to bring down this power 4. So we have 4 times a constant. In this case, a is 3 is a constant, so it'll be 3x. Now you subtract 1 from the power, so you have 4 minus 1, and this is going to give us 4 times 3, that gives us 12x, and 4 minus 1 gives us 3. So differentiating 3x to the power 4 gives us 12x raised to the power 3. So that's it for the first example, B. We have the second example, B. We have to differentiate y 2x cubed plus 7x. Okay, again, we go by the general method, dy by dx, differentiating y with respect to x. So we bring down the power 3, so we have 3 times 2x. You remove 1 from the power, so it will be 3 minus 1 plus the power of x in this case is 1. So when you bring down 1, so you have 1 times 7x. Again, you subtract 1 from that power, and that simplifies to 3 times 2, that gives us 6x. 3 minus 1 is 2. So we have 6x squared for the first term, and 7 times 1 is 7. And 1 minus 1 is 0. So x raised to the power 0, which is simply 1. So in this case, we have 6x squared plus 7, because x raised to the power 0 is 1. So that's it for the second example. And then we have the last example there. C, we had y equal to 5. In this case, we are differentiating a constant. So what do we obtain when we differentiate a constant? That's what we are going to see right here. So in this case, dy by dx will be equal to, here, having just 5x is the same as having just 5, sorry, a constant, is the same as having 5 x raised to the power 0, because x raised to the power 0 is 1. So let's assume there's an invisible x raised to the power 0 there. So we are going to obtain, we bring down this 0, so we have 0 times 5 raised to the power 5x raised to the power 0 minus 1, and 0 times whatsoever follows gives us 0, and that leads us to the conclusion that whenever we differentiate a constant, we have 0. So differentiating a constant gives us 0. Okay, so that's it about the general method of differentiating, and we are going to be using this general method as we go along, even as we shall be looking at the other methods of differentiation. This general method is going to come in handy. So it's very important we know exactly how it works.